so lost. I want to watch again.
Yeah. Okay, I record it now.
Okay, wait. Next question, please.
Maybe I can post it in the times.
Yeah, you can just like send us the video later, or send me, and I will send my friends.
Okay then. Yeah. So you understand, huh? So it's a circle. Okay. Any other question?
So maybe 5B.
5B, huh? 5B. This one. Oh, this one. Okay.
Part 1 and part 2. Like,
part B.
is it like which value to put up and which value to put at the bottom on the formula? That's the question, sir.
Okay, I clearly said there are two ways of doing the 10 log.
Log P1 or P2.
The P1, let's say P2. I always
this
choose
for decibels, right, sir? If 10.
10 decibel. We normally use decibel. Okay. So okay, let's say I always put P1 greater than P2.
Yeah.
One way of doing, it's one way of doing. I always prefer the P1 greater than P2. So if it's an attenuation, if it's a case of attenuation, then let's say this is the input, okay, and this is the output. So definitely, if it's an attenuation, where you put on top, you put input on top, output on top.
Input on top.
So you put input on top lah. My method. If it's amplification,
P2 is on top.
P2 on top lah. So for if it's an attenuation, use this formula with putting bigger value on top. You will get a positive decibel. You get a positive decibel for attenuation. For amplification also, you'll get a what? Positive decibel. Okay. But let's say there is a question where got attenuation, after that got amplification, both happens concurrently. Okay, you got attenuation. Let's say this is, according to your formula, you got 10 decibel attenuation, and the amplification you get positive 50 decibel. Okay, then later you got again attenuation of 10 decibel. Okay, according to your formula, if you use the method I chose teach you, all will become positive, But if they ask total, is it total? Is it attenuation or amplification? When you deal attenuation amplification together, now you have to be careful. Now what you do? The attenuation, don't take it as positive 10. You have to take it as what?
Negative
10. And the amplification you take it as positive 10, positive 50, and again attenuation negative 10. So total is positive
30.
That means what you must imagine that throughout this attenuation, amplification, attenuation, what finally happened is an amplification of positive 30. Okay, so these two, let's say you get an input here, you have input here, and you have the output here, the final output lah. Okay, so how do you put into the formula the input and the final output, which costs 30? How do you put that? So
you put 30 over the.
So 30 equals to 10 log. What? On
10
top,
log. On top is the P mean.
In or output, you put on top. You put
out.
You put out on top.
Yeah, because of amplification.
Input you must put down. Why? Because this is very clear. Positive 30. Positive 30 means input big or output big.
Output
big. So according to my idea, put the big power on top. So in this case, output must be on top, input at the bottom. You put here positive 30 and works. Yeah. Okay. This is how my method lah. I've got attenuation, amplification together. That situation where you must consider that attenuation as negative, amplification as positive. Okay.
So there's so many. Oh, never mind.
Okay. Yeah. So those who are, this is a new topic, but as I said, when I teach you this, it's a very rigid question, It's rigid. If you go 10 years of past year of this telecommunication, these cable questions, the question is about, more or less about the same style. Okay. But it's something new, that's why it looks for you very difficult. go through 10 years of papers, read the PowerPoint, 10 years of papers. You will, I think after 5 years later, 5 years of papers, about 10 or 15 questions later, you already, more or less, you know already what to do. It's rigid question. Okay. So, so Abhilash, you got a problem with this answering? You want me to explain? Okay.
No, sir. Actually, I was confused, but where to put which power?
So let's say, so this question, the constant noise power is transmission. This is your noise, It's a noise, right? The minimum acceptable noise ratio is 32. The minimum acceptable signal to noise ratio is 32. That means 32 equals to what? 10 log?
10 log.
This your, on top is signal power or noise power?
Oh, on top is signal power, sir, because they say signal to noise. So noise is down.
Noise is down, 7.6 is down. So you get the minimum power, minimum signal power. This is the signal power, but what? Minimum per meter. So you get the minimum power. So that's
so then the next question.
Next question. Okay, let me go through the next question. Yeah.
So then after that, they say the input power of the signal is 2.6. So now we have to use 1 over L 10 log formula.
The input power, the signal transmission is 2.6. That means this cable, the input is 2.6. 2.6.
Yeah.
But the minimum output we know already, right? Output we know already, right? The minimum. That's
why we consider it as output, sir, that one?
That's the part one answer. Yeah, because
why do we consider that as output?
Because as I told you, why are they looking for minimum power? What is the reason they're looking for minimum power? Because they want to see the maximum length we can use so that we can put the amplifier.
Yeah.
Yeah, that's the purpose we are doing this part, right? To save money for the company. Okay. Find the minimum power so that we can use a maximum length of cable so that we can put limited number of amplifier, because amplifier costs money. So therefore, you should understand the output here is the minimum power.
Okay.
So now you know how to do this.
Okay, sir. Then it's okay already.
Okay. Okay. Any other question? Anyone?
So 7B part 4.
7B part 4.
7B part 4.
This one.
Mr. Anna, can I ask you something later in WhatsApp about?
After this. Okay.
Yeah.
Okay, can.
So this question.
Yeah.
I just used the V over I formula, sir.
V over I formula. V over, okay.
But the V I need to use 2.8, right, sir?
2.8. When the op-amp is saturated, the potential difference across LED is 2.2. Calculate the minimum resistance of R so that the current in LED is limited to 20 milliampere.
We're using V equal to IR? No.
R is V over I, so...
R, do you know? Calculate the minimum resistance of R.
In the diagram,
Okay, we got that in the diagram. So they're asking what is the minimum resistance of R? Minimum resistance of R. So the current here is 20 milliampere.
So why the current throughout that part is 20 milliampere?
They said it one.
Is it throughout is that whole line is 20 milliampere?
Yeah. Whole line is 20 milliampere. Calculate the minimum resistance
How
R
do we
so
know
the current in LED is limited to 20 milliampere. So, so current here is, sorry. Okay, current here is 20 milliampere. So current here 20 milliampere. That means they're asking what is the minimum resistance in the LED must be. But do you know the voltage here? Voltage here.
No, minimum resistance of R, sir, the resistor.
Yeah, they want the minimum resistance of R. Who's Brian? Brian,
Brian. Normal Brian, I hope. Brian, speak.
No, admit him first. Let's see.
Let him speak.
Okay.
Brian, speak.
Hey,
Oh,
Brian,
same.
what's your name?
What, Brian? What's your name?
Ask him. Brian, what's your
It is
name? No,
it is
his
Brian.
hand is name.
He mute.
Hey, Brian,
It's muted. Muted.
Right.
what's your name?
It is Brian. Tell your full name. Your full name.
What's your name?
Why?
This is Brian. This is Brian.
Brian, what's your name?
The
His name
picture
What's your
obviously is
full name?
Brian lah.
Hold on,
Yo.
what's your
No,
full name?
Brian.
Come.
The picture is him.
Picture is Sam.
Bro, you guys are paranoid.
Yeah. This one.
Okay.
Oh, Ahmad, why do you text me?
Okay. Yeah. Okay. We see not any interruption. Okay. So they want the R.
Yeah, sir.
They want the R. Go back. They want the reach the R. Yeah. They want the R. Okay. Correct. Okay. So you understand? So how do you find the R? So V equals IR.
Because they say the PD across LED is 2.2.
The PD across LED is 2.2. Oh, here 2.2 means here should be how much?
2.8.
2.8. Yeah. Okay. So
Because
V,
it's 5 right, sir, total.
yeah. So V is 2.8. R is we don't know. I we put 20 milliampere. Change to ampere. So you can find the resistance radial.
Yeah, okay.
Eh?
Yes, sir.
Okay. Any other questions?
So next 8 part C.
8 part C.
Yeah.
The
So
current in Y and Q are different in
Remember
magnitude.
the use of EQ mode.
Okay. You want Shannon again?
Yusuf? Hold on.
or
Yusuf?
maybe he's using a different device, that's why.
Oh, okay.
Let him in. Let's see.
Yeah.
Wait, what's
Maybe,
your name?
Who's the name?
Okay, let's see.
Okay, which question? 8.
8, yes, sir, 8.
Who's this? We don't let him, huh?
So don't.
Okay, so yeah. Which question? Number 8.
Question 8, sir.
Okay, so wait. Can you wait? Wait, I'm leaving.
8 which part?
So, okay, sir, just one question, sir. Okay, so 8 part 1,
Yeah.
we use the formula, right, sir? But the current we are using of current of wire P, right, sir?
Part 1. The magnetic flux density is Q due to the current in wire P. Current
So
in
we
wire-
have to use the current of wire P, right, sir?
Yeah.
But the second question, sir, I use the formula F equals to BIL, then F over L is BI.
F
So
over
the current, why do we use the current of wire Q instead of wire P?
force per unit length. So they want F over L is equals to BI. Okay.
BI, yes.
Okay. If it's the you want force, let's say you have 2 wire. Let's say you want the force on wire 1. Force on F1. If F1 means, if you want the force on wire 1 means the B must be B of 1 or 2.
B of 2.
B of 2. I of 1 or 2.
I of 1, sir.
I of 1. L of 1
Why,
or 2.
sir? Why is it like that?
Yeah, the current is BIL. BIL, the formation of BIL formula. The BIL formula. The force is actually the current flow through the conductor one who experienced the force.
Sir, but one question, sir.
Yeah.
The magnetic flux density, the first part, we use the current of the wire P.
Yeah.
The second question also says due to the current in wire P. Why don't we use the current of wire P?
The force acting due to the current in wire P. The force per unit length acting on wire Q. Wire Q. The force on wire Q. That means they want the force on Q. That means the B must use B of
P.
And I you must use I of
Q.
I of Q. L you must use L of Q.
L of Q. So, but why the magnetic field is different, but the current we use the same thing, sir?
Magnetic field difference, current is the same.
Enter the.
Current
So what I mean is,
Oh,
I'm referring to two questions at a time, sir.
this is magnetic flux in YAQ. Magnetic flux.
This one is
current in
P. So this one we use the current of P.
The magnetic
But the
flux
second
density at
question,
YAQ due to current. Yeah, you must use current of P.
but the second question we didn't use P, we used Q.
I want to enter. Joseph, I want to show one.
The magnetic flux density at YAQ due to current in P.
Yes, sir. Yusuf want to enter.
Oh yeah, who's that?
Yusuf.
Oh, Yusuf.
I don't know. Even Fizz got kicked out. I don't know why.
Okay, see, magnetic flux formula given. This is the magnetic flux formula. You see,
Yusuf, I know, I'll try.
so let me clarify this one. You see, if you have, this is YAQ, this is your YAP, YAP, okay? Okay, let me start from the beginning. Here, at this point, the magnetic field, the YAQ, the magnetic field of P, the magnetic field, okay, the first question here, asking for magnetic field of P or magnetic field of Q?
Of P.
Of P.
P.
So you are looking for magnetic field of P, right?
Is it Q, sir? At YAQ due to
Yeah, the position is at Q, the position is at Q, but the strength, magnetic field of what? Magnetic field of P.
Yeah, because current
magnetic of P.
Magnetic field of P, right?
Yeah.
So magnetic field of P, the formula out there is mu naught I 2 pi R, right? 2 pi R. Okay. So the I, you must use this I of P1.
P.
I of P. So that's why here the first question, use I of P. Here in the second question, you want the force at Q. Force at Q. Force here, the force at Q. Force at Q is B of what? B of P.
P.
I of Q.
Q.
L. So that's why you use IQ. Okay. Okay.
So only the magnetic field strength, magnetic flux density only is different. The rest we use the same.
Magnetic flux is different. Yeah, correct.
But sir, why do you use P and Q in the same what? In the same formula? Isn't it different wire?
Yeah, it's a different wire. First, you see the first question they want, what is the magnetic field of P at Q? So it's about magnetic field of P, no? Okay, so magnetic field caused by the P, the formula is mu naught I. The I you must use is I of the P.
Okay.
Okay. So let's say ask, so next one they're asking, what is the force per unit length of Q caused by P? So they're asking what? Force on where? They're asking force on Q. They're asking what is the force experienced by Q? Okay.
Okay.
The force, why? The force experienced by Q because the magnetic field of P, right? P effects here. So what is the formula for magnetic field of Q? The force of Q, B-I-L. B-I-L.
Yeah.
B, which B use? B of Q or B of P?
B of P.
B of P. Then I of P or I of Q?
Q.
Q. Use Q. LQ. It's LQ.
But we don't need L, sir, because force per unit length. So F.
Yeah, they want the force per unit length. So you put the L the other side. So you see, remember, if I expand this further, the force at Q is actually equals to the magnetic field length of the P is actually what? This formula. Mu naught I P 2 pi R.
2 pi.
And outside you got I of Q and L of Q. So this is the actual formula for the F on Q. You see, you got IP and also IQ. Both are there. If you go FP means force at P caused by Q. Inside you get I, but inside you get IQ. Outside will get
IP.
IP. But the both force are
Oh, okay. Then that answers the third question already. That means, so force depends on the product of the currents.
yeah, the product of the current. That's why it's action direction path. The force is always,
That means the third question, part C, is same, sir. The force per unit length.
yeah, definitely it's force per unit length. Force per unit length.
So this answers part C already, sir. Yeah, okay. Thank you, sir. Thank you.
Okay.
Yeah. So, but how do we actually like put it across in like sentence, like, because you did based on expansion, like mathematical sentence. How do we like say
Part 3.
part C, sir?
The current and P and Q are different in magnitude. State and explain whether the force per unit length on the two wires will be different. No, it's going to be the same because the force is directly proportional to the product of the current, and it's an action reaction path. What is the answer given? 8, right? 8 here. Correct application, Newton's third law. Yeah, it's an action reaction path. Two currents, the same magnitude. Yeah, you have to link to the Newton's third law. The force between the two wires is an action reaction path based on Newton's third law. Therefore, force per unit length must be same, but in opposite direction. Okay, you always need to link to Newton's third law. I think one question, structured question, about similar like this in the notes. Okay, after I did these two wires, I go to that question. I think I can't remember. Okay. Yeah. So any other questions? So if you don't have questions, maybe tomorrow we go for paper 51.
Sir, just one thing, sir. There now is a bit, how to say,